Alright, um, welcome to Level 3 Physics 2019. This is going to be a bit of a different video, a bit of fun. I am about two-thirds of the way through the cider bottle, and the rule is going to be that every time I have to say or can't work out a question, I've got a drink. Every time I get one wrong, I've got a drink. So this is Drunk Top Scholar Speedruns Level 3 Physics. It's going to be kind of cooked. I just got to download this file and open it as a journal document. Yeah, this could be kind of fried. Hopefully, annotate PDF, my 1524, 2019. Okay, here we go. Now we're trying to start with. Excellent. Okay. State relevant physical quantity that's conserved during a collision. Oh, I reckon this is going to be momentum. Let's have a look. Oh, let's go. We got it right. What a great start that is. Okay, so we got at the end, Chris, move off at right angles to each other. Oh dear, what a cell. The speed of the collision is 1.7 meters per second. Alright. Momentum before is 60 times 1.8. So it's 108. Alright. Kg meters per second to the right. Okay, so therefore, like, Chris and Ali move at right angles to one another. Oh man, that's kind of fried. So like, V after is 1.1, so therefore like these, like the vertical components must be equal, yeah, because momentum up and down is conserved, so we got like, what's Chris's? Chris's 60 kilograms. Okay, so like 60 times 1.1, we got like 66 sine of, say, theta equals, what's Ali, 50 kgs, like 50 V sine 90 minus theta. And then like, we can say that 66 cos theta plus 50 V sine, no, not sine, fudge, skip that one up. 50 V cos 90 minus theta equals 108. So that's like the horizontal pieces, you know, this horizontal piece plus this horizontal piece. Okay, so this is simultaneous equations for theta and V. You only really care about V though. What sine of like 90 minus, what sine of 90? If I go into degrees, sine of 90 is like 1. So sine of 90 minus theta is like sine of 90 minus, say, 3 minus cos sine of 3. Okay, so this is like cos theta. Okay, so 66 sine theta equals 50V cos theta. And cos of 90 minus 3 minus sine of 3 is, okay, so that's sine theta. Okay, so we got 66 cos theta equals 50V plus 50V sine theta equals 108. Okay. That's interesting. if v equals 1.71, then 66 sine theta equals 85.5 cos theta, which implies that 85.5 divided by 66 is tan theta, so therefore tan inverse of that implies theta equals 52.33, and from this we would have 66 cos 52.33 plus 50 times 1.71 cosine 90 minus 52.33. We would have 108.010 equals 108. So works to SF. Excellent. I felt there's a better way to do that. I don't think you can really just sum them, but I don't care. It's good enough proof for me. No, vertical circular motion's cooked. Alright. Alright. He spins around. Top of it. Oh, all good. Okay, so to like make it over the top, the minimum speed. At minimum speed, like the reaction force is 0. So therefore, like mg equals mv squared on r. So v equals square root gr equals square root 9.81 times 0.7. So that's 2.62 meters per second. Excellent. Okay. The top and bottom. Okay, I'm going to do this in writing. At the bottom, tension equals Fc plus mg and is at maximum as the inertia of ball is Chris is pulling. Oh, that doesn't make any sense. Okay, is that a maximum? Describe and explain the size and direction of tension and weight forces. The weight force is constant throughout. Because Fc and T are parallel, this point is the maximum since there's a maximum. Yeah, all good. And Fc is largest here because kinetic energy is largest. So potential energy is lowest. Okay. At the top, tension is at its lowest since the centripetal force is being mostly supplied by gravity. Hence, not much tension is required to continue circular motion. Something like that seems fair enough. I wonder what the answer says. No, I hope I don't have to drink. How did I get? I get 1.71 orbits. What do they do? I know it's like garbage. Radius 78, 2.62. Excellent. The weight force is constant. Yeah, I said that. The bottom tension is upward and much larger than the weight force, since the tension must overcome the weight force to provide. Yeah, the total tension will be 0. Well, I mean, like, not necessarily, right? It's not necessarily. Oh, at the minimum speed. Okay, I didn't read the question. That's kind of cool. I'll get myself E because who's gonna stop me? No, I have to drink. That's fair enough. I misread the question. I'm still giving myself 8 though. I put a little minus on. Alright, rotational inertia, let's go. Instead evenly spaced around the other edge, each yada 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 yada. Okay, assume the rotational. Alright. So I equals the sum mr squared equals 3 times 28 times 2.1 squared equals 3 times 8. Oh wait, that's fine. Plus 271 for round about equals 641.4. The total energy of the system is 388 joules. Okay, so this should be square root of 2e divided by m. I'm assuming weightless. 2 times 388 on m. That's a bit of work. Oh, okay, that's covered. Why? Can I get fried by an achieved question? Total energy. Okay. Oh wait, it's not m, right? It should be w equals square root 2e on I. 2 times 388 on 641. Don't get cooked. Let's go. 1.1 radians per second. Linear velocity. Okay, this is like v equals. What is that? It's like w and r or something? Or is it the other way around? Hang on. 1.1 on. Oh, it's definitely not that way around. I think it's w equals v on r, so v equals w r. I think. Must be, yeah. 1.1 times 2.1 equals 2.31 meters per second. What do you do? Alright. The torque produced by the foot. Okay. Acceleration equals t equals 1.1 on 2.8, which is 0.393 radians per second. Torque equals I alpha equals 0.393 times the torque times the rotational inertia of 641, which is 252 meters. Oh yes, it's the rotational inertia question. This is so free. Okay, angular momentum holds constant without external torque. When the children walk inwards, they lower the rotational inertia of the system. By doing so, the angular velocity increases proportionally to keep L constant. Remembering that L equals IW. Okay. We'll call that the initial energy is half I1 W1 squared equals half. I1 W1 is just L, because that's velocity. Okay. But final energy is half L W2. Since W2 is greater than W1, the energy has increased. This came from work done by the children walking. Okay, that was a slapping answer. Let's see if I got that right. Hang on, let's see if I got that right. First 252. Oh, excellent, excellent. Okay. That is great. Okay, that's correct. All those were show questions, so that's fine. Alright, let's see if I didn't throw. Mass distribution decreases if the decreases, sure, that makes sense. Angular is conserved, W, I said that. Proportional increase angular velocity. If it's proportional, let's go. Equi-rotational will increase. They didn't even explain like how the extra energy turned up. That's so dumb. That's a W. That's massive E marks. Let's go. Alright, question 3, swing. Yada yada yada. Oh no, it's the bottom harmonic motion, bro. Bro, small angle approximation can fuck off. Look at that. That's just a mess. Whatever. Okay, go to the maximum velocity. Alright. Um, okay, so like her amplitude y is equal to, no, sorry, her displacement y is equal to 0.31 sine or cosine, depending on when you start. 2 pi divided by the period, which is 2.4, so 5 pi on 6 times the time, or x, plus some phase constant. That's fine. Right, excellent. Okay, so like derivative of that is 0.31 times 5 pi on 6, which is about 0.81 cosine 5 pi on 6x. Therefore, about 0.81 meters per second. Surely. 0.81. Let's go. How do they do it? AW. Boring. They use the formula. Greater than from equilibrium over one period. Oh, cooked, bro. Cooked. Okay, so let's say that y equals 0.31 sine 5 pi on 6x. This looks something along the lines of, I'm going to look at this formula. Okay, so it's like, I'm going to graph this in my calculator. Sine 5 pi on 6x. And also going to put this into radians. Q. And we want just displacement to be greater than 0.2. Okay, so if he starts at the equilibrium position, looking at my graph I've got here, going into reference circle, just draw this graph in your graphics calculator and then draw the line 0.2 and negative 0.2. And you should see that the intersections are from 0.2678 to 0.932 and 0.2667 to, why am I doing 0 point? Should this be, yeah, it should just be 2.667 to 2.4, and now if we turn that one off and we put this one on, intersections are from 1.4678 to 2.132. Excellent. So that's, if we take differences, that's going to be 0.932 minus 0.2678 plus 2.4 minus 2.667 plus what happened there? Something has gone wrong. Don't like it when things go wrong. Oh, it should be period of. Oh, okay, that's useless. That's useless. I don't even want that. Okay, get out of here. This one is still useful, I think. Yes. Alright, so then we add the differences of these two, and that's 0.932 minus 0.2678 plus the difference between 2.132 minus 1.4678, and that's 1.3284 seconds. And okay, surely we haven't solved. 1.33 seconds. So what I have? Yeah, that's close enough. That's 1.33. W, let's go. Over the next 3 periods. You stop swinging your legs when your swing is at a maximum displacement. Okay. This can be 1 period, this can be 2 periods, this can be 3 periods. So like after 1 period, she's probably at here. She let's figure it out, right? After 1 period, we'll say she's here, and then like here, and then like here. So we'll go like. That seems good enough. Do 2 peaks and then W. Let's go. I seem to have labeled that right. That's fair enough. Oh my god, it's circular fucking pendulum or whatever it is. Kind of pendulum. Okay, so like the point between this one is that the weight force is going to be equal to the vertical component of the tension force, and like that's theta there. So mg tan theta. Okay, so Fc equals mg tan theta equals mv squared over r. And T equals mg secant theta, or yeah, right. Actually, we could just say T equals square root mg squared plus Fc squared. So T equals square root of 70 times 9.81 squared plus centripetal force is mv squared over r, so 70 times 2.61 squared on radius of 0.411, and we square that, and we have 1346091, and so that is square root of 70 times 9.81 squared plus 1346091 squared, and then I want the, yeah, alright, that can't be right. That is a stupid answer. That makes no sense whatsoever. What? Oh dear. It can't be that many units, surely. Ah, no, it isn't there. The angle. Oh, that's easy. Well, MV squared over R, like, okay, so tan theta equals V squared on GR, which is 2.61 squared on 9.81 times 0.411. 1.689, so theta equals, I'm in radians, I'm in radians. Tan, arctan of 1.689 is 1.036 radians. Okay, so the tension force is mg secant theta, or mg on cos theta if you prefer, which equals 70 times 9.81 divided by cosine of 1.036. So 70 times 9.81 on cosine 1.036, 1347 newtons. 1350. Alright, we take that. 59.34 degrees. What's radians to degrees? Fuck. 1.036 times 360 degrees on 2 pi radians. 59.36 degrees. Close enough, close enough, close enough. I'm giving myself 8 for that because no one can fucking stop me. W24. Alright. I'm gonna have a drink. And to be honest, I presume that wasn't very helpful. But it let me kill some time. So, good enough for me. Ciao.